Hi, can you hear me? All right, so hi everybody. So my name is Jennifer. I'm a principal data scientist with Walmart Global E-commerce. I do realize I'm the last speaker, so I am trying to keep it as fun and enjoyable as possible, so please bear with me. So today I'm going to present some work we've started very recently regarding review analysis. So, all right, so I'm going to start by telling you about the business motivations very quickly, and then I'll actually dig into the algorithm that we've developed so far. And I'll tell you really briefly about feature space computation, because this is something we're still working on, and this is something that's actually very complicated, and I won't have that much time to dig into the details, but I'll try to tell you what we're doing. And then I'll dig into the actual sentiment analysis part, and I'll spend more time on this side of things. And then I'll finish with a few real-life examples, and hopefully I'll have some time for future work and conclusions. So, I mean, for us at Walmart, it all starts with the customer, right? I mean, so on a daily basis, we have millions of customers that actually decide on a daily basis they're going to buy something, right? I mean, so in this guy's case, he's decided that he needs to buy a computer, right? But the thing is, you have lots of different options on the market, right? I mean, so what does it mean you need to buy a computer? And so you have lots of different brands and designs, and computers have lots of different applications. And so while you may know that you need to buy a computer, you don't necessarily know which model you should go for, and that actually makes it very complicated. So we're tech people, we kind of know what we're looking for in the computer, but think of the average person, right? And so not only that, but the different kinds of criteria that you're going to use when you're buying a computer, it's actually a very complex set of characteristics of features. And so here, when I'm talking about features, I really think in terms of decision criteria for the customer, right? And so you may, decide to buy a computer for its processor, its battery life, its dimensions, the price, etc., etc. And so it's really not an easy walk for a customer, right? But the good thing for us and the good thing for the customer is oftentimes they kind of know what they're looking for. They have a precise set of criteria that are their top criteria. So here you may have, for example, someone knows that they're looking for a good battery, and they're under a budget, so they need a good price, etc. So now it all starts at this point, right? You know you need to buy a computer, a laptop computer, and you're going to start to do some research online. And this is where reviews are actually useful. I mean, I think most of us actually start researching different products that could fit the bill, and but the thing is, there are lots of places where you have reviews, you have people blogging about things, and so you have lots of information, but that information can be occurring in several places, and some of this information might not be relevant, it might be biased. Here you have the example where someone left a review about buying a computer for their children, and so if you're a professional, it's not necessarily the same kind of criteria you would look at. And so this is kind of hard for the consumer if they won't make a smart decision, because they don't necessarily have the time to go throughout all the reviews that you can find online. So we're data scientists, and so we think in terms of, like, I would like to have some way of visualizing what people are saying about a specific product, right? So since I'm in the context of textual information, one of the popular ways of visualizing the data would be a word cloud, right? I mean, you can see on the picture here. But this is not really the right way to go about it, because for one, you don't really have a notion of sentiment in that word cloud. And you also may have cumbersome information. So here you can see that the word laptop came on top, but the word computer came on top as well. And so these are two words that are actually referring to the same feature, namely the overall product in general. So we wanted to do something about this so that people can see in what snapshot what people have been saying about one specific product. So before I start digging into the actual algorithm, I would like to spend like just 1 minute on telling you about the current landscape. So you know for sure that sentiment analysis is not something that's new. It's actually been around for quite a few years now. And so the best use case, the one that you see the most often, is definitely social media analysis or tweets. So why are tweets so popular in this era? It's actually because they're very short and they're very condensed, and they contain a lot of sentiment into it, right? And so we're kind of hopeful that we can do something cool with reviews, because reviews are actually, they have the same characteristics. And so if you can do something nice with tweets, hopefully you can do something nice with reviews as well. And so there was a Kaggle challenge a few years ago regarding movie reviews. And what people were trying to accomplish here is to try to understand what various movies were about by looking at the reviews that people were leaving, and they were also trying to understand whether they liked the movie or not. But there wasn't really a real effort to try to understand why people disliked a specific movie. So for example, I may really like such and such movie, but I may actually like the scenario, but I don't like the acting, right? And so this is pretty much in the same line of what we are trying to do, because we are trying to understand not only if people liked or disliked the product, but we are trying to understand what specifically we disliked about the specific product. And so, surprisingly, I mean, if you look at from a I mean, the scientific community didn't really have that many answers regarding a proper way of doing this kind of analysis at a commercial scale, right? I mean, so at Walmart we have lots of different products, so it's really important that we find a way to scale that up and do that in an online manner, and so that we can refresh our results very frequently, right? And so I also noticed that there was a shortage of work regarding ways to combine feature extraction, or you could call it topic modeling if you want, and sentiment analysis in a way to bring it all together and try to give, I mean, really what we're trying to accomplish here is create a product that would give a snapshot to the customer so that they don't have to go and read every single review by end. So now that you know that, I can tell you about the algorithm pipeline. So it all starts with a category. So here I've taken the category to be the laptops, can be anything else, obviously. And so we have quite a few different laptops that we're selling, and hopefully for each one of these laptops we can find some reviews and information left by the customers. And so the first step is basically you would like to scrape throughout all these reviews and try to extract top features, so top reasons why people like or dislike, or really like decision points for the customers. So in the example of a laptop, these might be picture quality, CPU, the general weight of the computer, the design, etc., etc. But the thing is, not necessarily all these features are relevant on a product-by-product basis. So if you take the example of a touchscreen laptop, it actually makes sense that the touchscreen is one of the top features that people are going to talk about, but if it's non-touch, you don't want to consider that feature in particular. So you have to compute a different feature space for each one of the products. But once you have that information, what you can do is basically go again throughout the data sets of reviews and scrape through all of them and extract a sentiment for each review on a feature-by-feature basis. And so then the last step would be simply to have some kind of aggregation of the results, so that you can just create a snapshot and see just in one screen what customers were saying about product A. All right. right. So again, I mentioned earlier that I was not going to deep very deeply into feature space computation because truth is it's actually very complicated. And so the first thing you have to do is like take the texts from the reviews and put them through a series of transforms like TF, IDF transforms, stop word removal, parts of speech selection. You actually have to do spell checking because spell checking is actually pretty important for synonym computation because word embedding is actually sensitive to it. And so we have lots of questions there yet because do you want to use term frequency or TF-IDF? Because using TF-IDF might remove some of features that seems to be repeating themselves for all products, and when really you would like to extract that feature because it's still very specific to a computer, for example. And so the second part of this feature space computation, I would say the hardest part is synonym computation. Of course, by synonym I mean related words. And so, again, you can do that using word embedding, and you have a few tools that are open source tools like Word2Vec that allow you to do that, or you can actually build like some kind of an entity graph that gives you, the relationship between the words and build some kind of a synonym graph. And so truth is, none of this is really a good answer for us. It's really, we have to build something which is a superposition and like a weighted version of these two different techniques. And so again, anyone who's done it knows it's complex, it's tricky, it's actually context sensitive, and so worst of all, it's unsupervised because, so that means that you have to have, it's very difficult to deploy as an online algorithm because you don't really know if what you're getting does make sense at all. So we're really like trying to think about the question right now, whether it makes sense to do that offline or to try to deploy that as an online algorithm. But now let's spend some more time on sentiment analysis. I'm sure you're aware of that. I guess it makes a lot of sense, but I think it's still worth repeating it. Sentiment is not Boolean, right? I'm not just happy or unhappy about a specific feature, or not even about a specific feature in a product. Really, sentiment should be considered as a superposition of different flavors of sentiment, so negative, neutral, and positive. And so if you look at it that way, you can represent sentiment as being a probability density function, right? So it would look like something on the top right. And so we're actually lucky because there is a package that's an open source package that was developed by MIT, which basically expresses sentiment exactly in this manner. And so you have on the bottom of the slide the example of what you would get if you feed one sentence to that package. And you would get these three flavors, negative, neutral, positive. And these would be numbers between 0 and 1, and they basically translate the intensity of the different flavors of sentiment. And then you have this fourth number compound here, which is basically translates like the proportion between neutrality and negativity and positivity. So the closer it is from -1, the more negative it is, and the closer to 1, it would be more positive sentiment in that sentence. And so the trick with that package is actually it was developed for social media. So it's definitely good that we have something like that that's available to us, but we may have to be careful to actually renormalize because the way people express themselves on social media can be quite different of the way they express themselves in product reviews. So here I just wanted to show you a few examples because this package is actually pretty cool. So this Vader module is actually sensitive to a whole range of different things that you could put in a review or in a textual comment, right? So it's sensitive to the usage of adverbs, of punctuation, of uppercase letters and emoticons, etc., etc. And so if you look at the first example, like this computer is a good deal, right? It sounds like it's saying something good about the product, but it's not over the moon good. I'm not super excited about it. So I would expect something which is kind of positive, but also fairly neutral, and I don't expect to see any negativity in it. And overall, I'm kind of happy about it, right? I mean, and this is exactly what you observe. So this is actually doing a pretty good job. But then I would like to try to take the polar opposite as well. So now I'm looking at the sentence, this computer is a bad deal. So guess what? I'm kind of expecting of seeing the polar opposite. And so this is kind of what I'm seeing, but you can still see that there is some asymmetry there, right? I mean, so it's not necessarily a problem, but this might be something that I need to keep in mind and renormalize when I actually build a product based off that, and I may need to do some post-processing on it. So now look at the bottom example. This computer is not powerful, so this doesn't sound good, right? I mean, so the compound is negative, the intensity of negativity is fairly high, not that high, but it's fairly negative, right? And so the cool thing is, like, if you keep adding adverbs and nuancing your sentence in some way, then the compound and the overall intensity of the sentiments keep changing, right? And this is really good because it's actually capturing the way people are talking, and it's capturing this notion of, like, people are more moderate in the way they talk, and they may have, some buts to put in their sentences, and so we are actually happy to see something like that. So how do you bring it all together, right? So remember earlier I was talking about getting features, getting reasons why people choose a computer. And so for a laptop computer, these features might be, I mean, some of the top features might be design and picture quality, for example, right? And so what I'm trying to do is, like, now that I know these features because I performed feature extraction on my data set, I'll go through the reviews one more time, and every time I see some mention to the design and to picture quality, I'm going to try to measure if people were happy or not happy, and try to get which one of the three sentiment flavor is the highest, and then actually get the intensity of the sentiment. And then by doing that for every single product, I'm hoping that I can get some short version of that, right? I mean, I want to aggregate the final results. So here you would have, for the example of product A, if you look at design, it looks like 3 people mentioned the design, and when people mention it positively, they were like 0.48. It's not that large, but just like, and if you look at all the different flavors, it looks like nobody said anything bad about it, and they were kind of spread between neutral and positive. On the other hand, if you look at processor, it looks like there was only one person who mentioned the processor, but they really had bad things to say about it because the intensity of the negative sentiment for processor is really, really high. And so again, I want to get the same kind of results for all my products. So once I get there, right, I'm hoping that whatever I created so far is going to make sense for my example. So I actually went on the Walmart website and I looked at 2 different laptops. So these are different laptops. They are not the same brand, but they're actually kind of similar. They have similar prices, and typically they would appeal to the same kind of customers. So we can actually go ahead and try to compare them. And so I'm actually going to show you the reviews that people left for these specific products. But first, I would like to show you what the algorithm was able to say. And so you had, so I mean, you can represent these results in many different ways, right? But I thought that showing them as radar chart was really pretty good. And so you have 3 different radar charts because you have 3 different flavors of sentiment. And so on the left you have the negative sentiment, the center is the neutral sentiment, and the right one is the positive sentiment. And so whatever you see in red is basically what people said about the first product, the A product. Whatever is in blue is the second product. And so I can really use that to compare things. So before I start analyzing these, I would like to say that look at the different edges of the radar charts, right? I mean, so it looks like the algorithm did a good job because it actually picked like the features that, at least personally, I would consider as being top features when choosing a computer, right? I mean, screen makes sense, weight, quality, battery life, performance display. Note that we actually have battery life, so we started playing with, like adding n-grams in our synonym set, and it looks like it's working well. And so for, now so if I try to analyze these different charts, if I look at product A, it looks like people that didn't have like major complaints about it, but they had more complaints about the overall quality than they did for anything else. And then if you look at the positive radar chart, the one you have on the right, you see that the one that actually seems to stand out if you compare it to product B is mainly the weight. So if my criteria is actually, I want a computer that has a good weight that I can transport easily, I should probably go with product A. And so you're going to ask me, okay, so what does the neutral thing mean in this picture, right? I mean, so my answer to that is basically when the neutral value is high, basically it means people talked about the product, but not necessarily, they didn't necessarily criticize it. So you may have a lot of mentions to, for example, weight or keyboard or whatever, but people didn't necessarily say they hated it or they loved it. They were just neutral. So the fact that the neutral value is high means you have a lot of description. People were very verbose about these specific features. So if you look at product A, I would say that quality is a problem, the weight is fairly good, and product B really seems to have a weakness regarding the battery life. I mean, this seems to be like the main negative value. On the other hand, if you look at positive, it looks like pretty much this product was a winner, right? I mean, people say that the keyboard was great, the screen was great, the battery life was great, so it really looks like it's a good product overall, except that people didn't seem to like the weight that much. So let's look at what you're actually getting when looking at these products, right? So the first product is actually, so it actually had 11 reviews, so not that much, but still apparently we were able to find some information out of it. And so my general feeling here is people said that it was light to carry, so it looks like people were happy about the weight. And it looks like there was one major complaint about the quality, so I'm fairly happy about it because this is pretty much what I saw on the previous charts. And so before I move on to the next example, I would like to emphasize this. The actual number of words that were used by people who left a review for that product was actually about 50, right? So if you compare that to the next product, that number is now 80. So it basically means that people were more verbose and more descriptive when talking about product B for some reason, right? I mean, I don't necessarily know why, but that's something I was able to determine from looking at the radar chart. And the good thing, if you remember about the radar chart, is also I was able to determine which features were features that people talked about. So this is not something I would be able to extract by just looking at the average number of words. So that's a feature that I get from building that algorithm. And so sentiment-wise, if I look at everything, it looks like people were happy about the screen, they were happy about the keyboard, they were happy about the screen, and so it makes a sense with what I had before. And I really see here that battery life seems to be a problem, and it seems to be a problem for quite a few people who left a review here. So it kind of looks like it works. So it's definitely work in progress. So I've shown you an example for electronics, but again, I've mentioned earlier that it's very context sensitive, and so if you do the same thing for like a home product or a grocery product, you may have to tweak your results. And again, because it's unsupervised, it's kind of tricky to do that without having a human look at the results. So synonym computation is definitely one of the things we need to put a lot of work into, and so that's definitely an area of focus for us. I also didn't have the time to mention, but there is actually a notion of bias in the sentiments. So it's actually biased two ways. So you remember earlier that I mentioned that the Vader module was not completely symmetrical when switching to polar opposites. But you also have an issue coming from the fact that So if you look at the average rating that people leave on the Walmart website, it's actually around 4 instead of being around 3. So basically it means that there are more better reviews than bad reviews. And this is not necessarily a problem. It's actually, it's pretty much natural, because it means that if there are lots of bad reviews for a specific product, then people won't buy the product. And then over time, pretty naturally, people will start, like a specific product has good reviews and keeps having good reviews, otherwise it just stops. Another problem we're trying to solve is, what do you do if you don't have any reviews? And that's definitely a big problem. So we're trying to see whether we can actually forecast things or expand to nearest neighbors and things like that. So this is actually a pretty cool project, because here I've mentioned the application to product reviews, but we also have lots of other kinds of reviews we may want to look at. I mean, so we can deal with seller reviews and people's email, customer care, and things like that. So more to come in the future. Thank you for your attention.